Hello and welcome to Chapter 4. This is going to be the first chapter where we start looking at trigonometry. Today we're going to specifically look at Section 4.1, which deals with radian and degree measure. Before we can start the trig section, it's very important that you understand these key definitions. When we're talking about trigonometry, we're typically talking about the measurement of triangles. The application of trig can be used in numerous fields. It's used in physics, it's used in calculus, it's used in astronomy. There's so many different applications that you can use trig in. Even in my engineering job as an exhaust development engineer, I use trig because sound travels in the form of a sine wave, which is trig. While we're talking about trig, we also have to look at angles. Now, if you recall, we did talk about this a little bit in Algebra 2. An angle is found by rotating a ray, and remember, a ray is a half line, and it's typically shown something like this. So we have a ray that's being rotated about an endpoint, the endpoint being something like this. We have the initial side of an angle, and the initial side is just your starting position of the ray. So I might have a ray that starts here, and we're going to have a terminal side, and the terminal side would be like this blue line here. And that's because my ray rotated from here, the initial side, over to here on the terminal side. The vertex of a ray is the endpoint, which would be this point right there. And you have the standard position of an angle, which is where the initial side coincides with your x-axis. So if I have an axis right here, this being the x-axis, and this being the y, a standard position angle is one that's going to have the initial side on the x-axis in the positive direction, and then your terminal side can be wherever the angle needs to be, so we'll just draw it over here. So your angle then is going to be this measure right there. So to reiterate, we have an initial side, which means this is a side that our angle is starting on. We are going to rotate that initial side to another side, or the ending side, which is our terminal side. The angle that's formed in between the initial side and the terminal side is the angle that we're talking about. Our angle has a vertex, which essentially connects the initial side and the terminal side. And we're going to get to this here in a second, but angles are typically measured in the counterclockwise direction. That's why, if you've noticed, we've always been moving in the counterclockwise direction here. An angle in standard position means that our initial side falls on the positive x-axis, just as is shown right here. We're going to rotate around in the counterclockwise direction to our terminal side, which is the ending side of our angle. Now, when we are talking about positive angles, it is very key that you know that we are talking about angles that are being rotated in the counterclockwise direction. And kind of as a shorthand, I'm going to use the CCW for counterclockwise. So positive angles go in the counterclockwise direction. Negative angles go in the clockwise direction, or the CW direction. Coterminal angles are angles that have the same initial and terminal sides, and I'm going to show you what an example of that looks like here in just a second. Now, one thing I also wanted to reiterate was that angles are usually represented by Greek letters, and we have Greek letter alpha, which kind of looks like the A, beta, which kind of looks like the capital B, and this letter here is called theta. These are nothing more than variables. It's kind of like you using X or Y or Z, but they're just Greek letters that usually mean an angle. Now we can also use capital letters being something like capital A, capital B, capital C, and so on. So capital letters or Greek letters usually are used to represent an angle. And again, just to reiterate, positive angles. This is an angle in standard position because our initial side is on the positive x-axis. A positive angle is going to rotate around in the counterclockwise direction, and a negative angle will then rotate in the clockwise direction. This is our representation for coterminal angles. And a coterminal angle means that two angles have the same initial point and terminal point. So if you notice, angle alpha, which is this angle here, starts in standard position right here, rotates around in the counterclockwise direction, and falls in this third quadrant here. Meanwhile, angle beta also starts in the initial position, but it's rotating around in the clockwise direction but has the same terminal side. These two angles, alpha and beta, are different, but they both share the initial and terminal sides. Likewise for this diagram over here, alpha is starting off the initial side and rotating just that little tiny bit. Now if you notice, beta is starting from the initial side, but it's going to go over and continue to go around, so it's going to have a lot more than angle alpha. But again, alpha and beta are coterminal because they have the same initial and same terminal sides. Now we're going to look at radian measure. When we measure an angle, we can use two different units essentially. One is degrees, which I think you are most familiar with. We're going to talk about that here in a little bit. Right now we're going to talk about radians. Radians is something that we are going to start using more frequently in the trig section. A radian is defined as the measure of a central angle, and if you remember, the measure of a central angle is essentially just, let's see, if we have a circle and it's drawn like this, the central angle of a circle is one whose vertex is the center of the circle. So if I take and I draw an angle and I have something like this and this, my central angle would be something like that. So the central angle intercepts an arc S that is equal in length to the radius of the circle. And we're given this relationship as theta equals S divided by R, where theta is always measured in radians. This is a formula you should probably write down because it's very important and we're going to use it some more. So here's a little bit better diagram. As you'll notice, we have a central angle with radius R, central angle theta, and we know that arc length, which is what S represents, is equal to the radius. So this length here, if I were to straighten it out, would really equal this right here. That is the definition of 1 radian. In order to get a feel for what 1 radian is, let's look at the circumference of a circle. We know that the circumference of a circle, or the distance around it, is equal to 2 pi r. So if we use a circle of, let's think about this in degrees for a second, 360 degrees, we know that the arc length, which is S, is equal to 2 pi r. So if S equals 2 pi r, then I know that if I have 1/2 of a revolution, that's going to give me 2 pi divided by 2, because I'm assuming that the radius is 1. So half of a revolution is 2 pi divided by 2, which is pi radians. Well, based on that right there, I know that I'm going to have 2 pi radians for every 360 degrees, or 1 full revolution. If I have 1/4 of a revolution, I'm going to take 2 pi, divide it by 4, and I end up with pi over 2. If I have 1/6 of a revolution, I'm going to take pi over 2, divided by 6, and I end up with pi over 3. So this is kind of just an idea as to how we're coming up with the number of radians that we're looking at. And if you think about it, if I have 2 pi radians in one circle, or for every 360 degrees, that's going to give me a little bit over 6 radians, because 2 times pi is a little bit over 6. It's approximately 6.28, and so on. So just to give you a picture of that, we'll show you that this radius here is equal to this radius here, this arc length. So this is 1 radian, 2 radians, 3 radians, 4, 5, 6 radians, and then I have just a little bit extra Okay, so that's why we say we're a little bit over 6 radians for one full revolution of a circle. And if one circle is 2 pi radians, then half of my circle is going to be pi radians. So when I'm looking at pi over 6 radians, I'm going to take my top half, or pi radians, and divide it by the number that's in my denominator. So in this case, I have pi over 6. So here's 1, 2, 3, 4, 5, 6 radians. So that would give me 6 pi over 6, or pi radians here. And if I want pi over 6, I'm just looking at this little segment right here, because that's 1/6 of that top half. Likewise, if I want pi over 4 radians, I'm going to take my circle, divide it in half. This is going to give me pi radians, and then I'm going to divide that into quarters. So I have 1, 2, 3, 4, and pi over 4 then is going to be this right here. And that pattern is going to continue on. As you'll see, we have pi over 3, which is just this little piece here. Pi over 2 is right here. Pi radians is the whole top half. And 2 pi radians is one full complete revolution. So, for example 1, we want to find the a coterminal angle for the positive angle of 9 pi over 4. So to do that, we're going to subtract 2 pi. So I have 9 pi divided by 4 minus 2 pi. Well, I'm really subtracting fractions. So when I subtract fractions, I must have a common denominator. To get a common denominator, I'm going to use 4 as my denominator. So I really have 9 pi divided by 4 minus 2 times 4 is going to give me 8 pi divided by 4. 9 pi minus 8 pi will give me 1 pi divided by 4. So my coterminal angle to 9 pi over 4 would be pi over 4. I'm going to do the same thing for B. It says for the positive angle, 5 pi divided by 6, we want to subtract 2 pi to find the coterminal angle. So I'm going to end up with 5 pi divided by 6 minus, my common denominator is going to be 6. So 2 times 6 is going to give me 12 pi divided by 6. And 5 minus 12 pi will give me a negative 7 pi divided by 6. So a coterminal angle of 5 pi over 6 is a negative 7 pi over 6. And last but not least, for part C, it says for the negative angle, negative 3 pi over 4, we want to add 2 pi to find a coterminal angle. So I have negative 3 pi divided by 4 plus 2 pi. And again, I'm adding fractions now, so I need to get that common denominator, which is going to be fourths. So that's going to give me plus 8 pi divided by 4. Negative 3 plus 8 is 5 pi divided by 4. So a coterminal angle to a negative 3 pi over 4 is 5 pi over 4. We also have to review the concepts of complementary and supplementary angles. If you remember, 2 positive angles were complementary if their sum was 90 degrees. That's what you guys used in geometry. Well, now we know that 90 degrees is really pi over 2. So if I take 2 angles and add them together in radians and I get pi over 2, then I have complementary angles. Supplementary angles were if I were to take 2 angles and add them up and get 180 degrees. Well, now we're not dealing with degrees, we're dealing with radians. So 2 angles that will add up to pi radians is going to give us a supplementary angle. So for example 2, we want to, if possible, find the complement and supplement of the angle that's given. So for part A, let's look at the complement. We know that complements have to add up to pi over 2. So I'm going to set this up and say that pi divided by 6 plus some angle is going to give me pi divided by 2. So in order to find x, That tells me that I have to subtract pi over 6. So x is equal to pi over 2 minus pi over 6. I need to get common denominators, which are going to be 6. So I'm going to have to multiply this fraction here by 3. So I end up with 3 pi divided by 6 minus pi over 6. And I end up with 2 pi over 6, which is really equal to pi over 3. So pi over 3 and pi over 6 are complements of each other. Now, I'm going to do the same thing, except now I'm going to look at the supplements. Okay, for the supplement, I know that pi divided by 6 plus x is going to equal pi. Therefore, x equals pi minus pi divided by 6. And again, I have to have a denominator of 6. So I really have 6 pi divided by 6 minus pi divided by 6, which gives me 5 divided by 6. So 5 pi over 6 and pi over 6 are supplementary angles. Now we're going to do the same thing in part B. I want to find the complement. So for the complement, I have 5 pi divided by 6 plus some angle x is going to give me pi divided by 2. That tells me that x is equal to pi divided by 2 minus 5 pi over 6. When I get common denominators, I have 3 pi divided by 6 minus 5 pi divided by 6, or I end up with a negative 2 pi over 6, which is really a negative pi over 3. Well, if you recall, the definition of a complement said two positive angles were complementary. I just calculated a negative pi over 3, so that tells me that I have no complementary angles. I still may have a supplement though, so I still need to try that out. So for a supplementary angle, we know that if I take 5 pi divided by 6 and add it to x, I should end up with pi. Well, again, we have to get a common denominator. So x is going to equal pi minus 5 pi over 6. My common denominator is going to be 6's, so I have 6 pi over 6 minus 5 pi over 6, which gives me pi over 6. So the supplement is 5 pi over 6 and pi over 6. Now, just to refresh, a degree measure, which is denoted by this symbol here, which means degree, is equal to, or means that 1 degree is equal to 1 divided by 360, or it's 1/360th of a complete rotation. And that's because there are 360 degrees in one full circle. Now with that piece of information, we know that 1 revolution is equal to 2 pi radians, which is equal to 360 degrees. So we have 2 pi radians is equal to 360 degrees. And if I simplify that ratio and divide everything by 2, I have pi radians is equal to 180 degrees. So my relationship between radians and degrees is this right here. And your book has a table in it, and you can look at it if you want to. It's on page 286, and it tells you that if you want to convert from one to the other, it gives you 2 formulas. You don't have to memorize those 2 formulas if you know this ratio right here. Pi radians equals 180 degrees. With that, depending on what you need, you can rearrange this and say that if we want to convert to radians, I need to divide by 180 degrees. And if I want to convert something to degrees, I have to divide by pi radians. And I'm going to show you how to do this using the unit analysis that you probably would be using in your science class. Just as a visual Now this might be kind of confusing, but essentially what you're doing is, if we look here, 30 degrees, which is right here, is equal to 1/12 of 360 degrees. And you can do that for any of these. 45 degrees is really 1/8 of 360 degrees. 60 degrees is really 1/6 of 360 degrees, and so on. Now, for example 3, we want to express each angle in radian measure as a multiple of pi. So I'm going to convert from degrees to radians, but I'm not going to use my calculator, and I'll show you why. In your science classes, you would typically set this up as 60 degrees, and I want to change my units from degrees to radians. Well, I know that degrees have to occur down here, radians have to occur in the top. I have pi radians for every 180 degrees. What I'm going to see then are my degrees are going to cancel, and my unit's going to be radians. So now I'm going to take and go 60 divided by 180, which is going to be 1. I still have my pi in the numerator, divided by 3. So I end up with pi over 3 radians. And you can rewrite that as pi over 3 if you would like to. You don't have to include radians, because when you have pi, actually any number that does not have a symbol with it is assumed to be in radians. So if you're given a number just like 2 or 10, you always assume it's in radians unless it has a degree symbol behind it. We're going to do the same thing for degrees or for part B. We have 320 degrees. I want to cancel out my degrees, and I'm going to convert over to radians. I know I have pi radians for every 180 degrees. So my degrees are going to cancel. 320 divided by 180. That fraction will reduce down to 16 pi divided by 9, and that's radians. Likewise for part C, I have a negative 30 degrees. I want my degrees to cancel out, so that's going into my denominator. I know there's 180 degrees for every pi radians. My degrees are going to cancel, left with radians, which is what I want. And a negative 30 goes into 180, so this is going to give me a negative pi divided by 6 radians. Now we're going to do the opposite. Here we're going to be converting from radians to degrees, and I know that I have radians because it doesn't specify. So let's set this up. Here we have pi radians divided by 6, and I'm going to convert that. I want radians to cancel, so I have radians down here, and I'm going to put degrees up here because that's what I want. I have 180 degrees for every pi radian. So my pi radians are going to cancel out, and I have 180 divided by 6, which is going to give me 30 degrees. Likewise for part B, I have 5 pi radians divided by 3, and I want to cancel out radians, which are going to go in the denominator, convert to degrees. There's 180 degrees for every pi radians. So my pi radians are going to cancel. I have 5 times 180 divided by 3, which is going to give me 300 degrees. And for part C, we have 3 radians. I'm going to go 180 degrees for every pi radians. When I cancel out my radians, I'm left with 3 times 180, which is 540. Now my radians canceled out, but I still have this pi down here, so it's really 540 divided by pi. If you type that in on your calculator, you'll see that that's somewhere close to 171.9 degrees. But I would prefer that you left these with the pi's unless it asks you to round to a specific number of decimal places. As far as examples go, this is where we're going to end for right now. I would highly encourage that you watch 4.2 video because that's going to be the story problem type examples that are going to be in this section. That is on day 2. However, if you get these types of problems done in class, then you can go ahead and start the next day's story problems in tomorrow's assignment if you'd like to. So if you have time, go ahead and try to watch the second video tonight. Now, in honor of this week being College Awareness Week, I went online and I wanted you to know that these are some of the fields that require mathematics. Now, there's hundreds and hundreds and hundreds more that require mathematics, but these are just kind of a few that you may be interested in going into. Something like animators, and that would be like people that make movies like the Toy Story movies. Forensic scientists, doctors, engineers, insurance sales workers, optometrists, sociologists, tool programmers for people that work in tool and die shops, veterinarians, carpenters, architects, surveyors, dentists, nurses, farmers. Numerous fields require mathematics. So regardless of what you decide to do when you are done with high school, you are most likely going to require some form of mathematics. So remember that everything that you are learning is very important, since we don't always know what we're going to do next year, let alone 10 years down the road. With that, have a good night, and I will see you in class tomorrow. Thanks.